Thank you, Dr. Data. It is certainly a great honor and a pleasure for me to address such a distinguished audience. And I would like really to thank the organizers, particularly CIMMYT, for giving me this opportunity to speak in such an important event for a great man and a great scientist. A man with vision, with dedication and commitment to the point that he saved the world, famine in the 80s and the 90s, and up till now, what he has done to us continues to have its benefits. So we, from ICARDA side, would like to pay tribute to this great man and great scientist. I will be talking about Central West Asia and North Africa, the main drivers of increased wheat productivity in the past, the current challenges, the role of ICARDA in generating and promoting wheat technologies in collaboration with partners, and I want to underline partners, bridging the yield gap and the impact of improved wheat technologies in selected countries, partnership, future emphasis, and looking ahead. Now, wheat is certainly a stable crop of strategic importance in that region, and I want to mention that it covers 54 million hectares, which is about 50% of the wheat production area in the developing world. The highest per capita consumption of wheat, which is the highest in the world, is in Morocco, with 220 kilograms per capita per person, per capita per year. And lifting subsidies in many countries of that region did create riots as well as unrest, and this good example has been in Morocco, in Egypt, Jordan, and other countries. Except for Kazakhstan, Syria before the unfortunate developments in 2011, and Turkey, all the countries of that region are wheat importers. Actually, that region is the largest food import region in the world. And Egypt is the largest wheat importer, and it imports up to 10 million tons per year. Now, looking at this slide, we can see the population growth, the consumption of major field crops. And as you can see, the consumption of wheat is way above the consumption of rice, maize, and barley. When we look at the importance of wheat, it provides 37% of the total food supply in calories, and the average annual per capita consumption is about 166 kilograms per person per year, while the world average is 66 kilograms per year. And currently, the region imports 50% of its wheat needs. Now, this shows the wheat area, the production and yield. You can see that the productivity of wheat has been really increasing steadily, while the area has really plateaued. As you can see from this here, you can see that the area is stable, while the productivity, which is the green line, is really going up. Now, this shows really the average net wheat importers in million tons. You can see a country like Egypt, 8.5. This is really an average between 205 to 211. Algeria, 5.6, 3.1. But anyway, most of the countries are food importing countries, and particularly wheat. And that's why when the increase in food prices erupted in 2008, those countries' trade balance has been really affected greatly, as you can see from the red I would say, the red part of this map. So the trade balances was seriously affected, and that's why many countries of the region started to move from self-reliance, which the World Bank advocated, to self-sufficiency. But of course, one has to question, is this the right way to go? There are really two main drivers of increased wheat yield in the past in that particular world. First of all, the adoption of input-responsive semi-dwarf, widely adapted wheat varieties, and this is the work of Dr. Norman Borlaug, and the adoption and the application of inputs, particularly fertilizer, irrigation, water, herbicides and other inputs, and the International Wheat Improvement Network and capacity development by CIMMYT and ICARDA, and of course other partners, the increase in the international prices of wheat, the favorable policy environment and government subsidies, and the point that I wanted to make, before 2008, the ministers of agriculture and ministers of planning were not putting agriculture high on their priority. But when they start paying high bills for the imports, then they started thinking about agriculture, and agriculture is now high in their agenda. And of course, to the lesser extent, the change has been due to the increase in area in some places. As a matter of fact, the only two countries where area is available is Sudan and Kazakhstan. Now, the current challenges for increasing wheat production in Ciudad, of course, water scarcity is a major concern. We are having now much more frequent drought, soil degradation, reduced supply and increasing cost of inputs, the climate change and the global warming, emerging pests and diseases because of global warming, increasing demand for energy and biofuel, increasing world population, which will be 9.2 billion people in the year 2050. This is a very scary map when we look at the relative change of mean annual precipitation in the coming 100 years. This is the scenario of 18, this is the, I would say, the average of 18 different scenarios, global scenarios for climate change. The brown part of this map, which is really the Mediterranean basin, will be losing between 10 to 50% of its precipitation in the coming 100 years, in a region which is already water scarce. So climate change implications will be the most serious in that part of the world. Of course, the other major constraints for wheat production, the abiotic stresses, I don't have to go through these. The biotic stresses, particularly yellow rust, stem rust, and of course the other insect pests like the Haitian fly, the Russian wheat aphid, and sun pest. This shows clearly the impact of drought on wheat production in Morocco, which is where agriculture is mostly rain-fed agriculture. You can see the fluctuation, which very much reflects really the precipitation in that country. The other major constraints, as I mentioned, is a good example is the stripe or yellow rust, which is the most economic disease of wheat in Central West Asia and North Africa. What's the role of ICARDA in generating and promoting wheat technologies in collaboration with partners? First of all, ICARDA has 36 years of experience in basic and applied research in non-tropical dry areas. It was established in 1977. We work on the conservation and use of genetic diversity of crops and wild relatives of importance to those areas, crop genetic improvement through plant breeding, biotechnology, and improved crop management of winter cereals, food, legumes, and forage crops, plant protection through resistance tolerance to biotic stresses and integrated pest management, enhancing water productivity and integrated sustainable water management, diversification and sustainable intensification of production systems, and this is in the favorable areas, while in the marginal areas, we work on the resilience of the production system. And these two major approaches are really followed in the CGIAR dryland systems. Now, the other work that we, of course, work on is conservation agriculture with minimum tillage to conserve moisture and reduce the cost of production and energy use. And the other work we do is on social, economic, and policy research and institutional innovation, because we consider the socioeconomic aspect should be an integral part of any research work being done. Capacity development and networking, this is certainly also a high priority. Now, what are the objectives of the wheat genetic improvement program? High yield potential and broader adaptation, durable resistance, tolerance to major diseases and insect pests, tolerance to drought, heat, cold, and salinity, grain equality, capacity building of national partners, and networking. This is an example of course, when we talk about the crop improvement, you need a genetic variability, and you need a germplasm. This is the total, I would say, germplasm that we have in our gene bank in Aleppo, which is now duplicated outside Syria. And I have to mention in wheat we have about 37,800 accessions, and we have the largest collection of wild cereals and wheat wild relatives, which is about 8,200 accessions. I want to mention all what's in this gene bank on land races, not improved genetic material. Now, the approaches that we follow is the classification and targeting major environments, shuttle breeding, biotechnological tools, including marker-assisted selection, mining desirable genes, and the use of wide crosses involving wild relatives, particularly working on synthetics for desirable trait, and screening for durable resistance and tolerance to diseases and insect pests, and this is being done in multi-location testing. ICARDA works now in key major locations for wheat shuttle breeding. We are working really in Morocco, particularly for rain-fed wheat and drought tolerance. We work also in Ethiopia particularly for selection for biotic stresses, Egypt for high input agriculture, and of course in Lebanon now, because Syria, we suspended our activities. In Lebanon, we work also for high yield potential, as well as we work for seed multiplication, and we provide the international nurseries. We have also work in Sudan, where we are working on heat tolerance, and there will be a platform developed within the CRP on wheat, as Dr. Hans Brown mentioned before, on heat tolerance. And we work now in Izmir, Turkey, on wheat rust, as well as we work with Summit and Turkey on the International Winter Wheat Program, which is hosted by the Turkish government. Now, one thing that ICARDA does in terms of identifying variability is we work on a focused identification of germplasm strategy, where we link the environmental data to the collection sites. We choose accessions from those environments that would impose a selection pressure for a given trait. For example, for heat tolerance, we select material from environments where there is a selection pressure for heat. On that, we managed to identify several desirable traits for sun pest resistance, Russian wheat aphids, Seychelles fly, salinity, and other traits. And we are also working with really combining, for example, screening 732 wheatland races and wild relatives have been identified through figs, where we have found that with high combination of resistance to yellow rust or stripe rust and septoria, and you can see the different wild relatives of wheat will have these desirable traits closely linked. This is again association mapping for yield potential, drought tolerance, and stripe rust, and the contribution of synthetic varieties which are developed through the crosses with wild relatives provide us with a very wide range of desirable traits. I don't really have to go through because of the time limitation. Now, when we look at the grain yield of the synthetic bred wheat that we are working on, you can see that there is a big difference really between the synthetics and the best improved lines. The blue line here that you can see is really the synthetics. This is really in very dry environment. This is in about 350 millimeter of rain. And this is really in a better environment, about 450 to 550 millimeter of rain. So there is really a big difference in terms of the productivity. The yellow is the improved variety called CHAM6, and the green is really the population average of the germplasm. This is one example of a synthetic that is very tolerant to excessive drought. This has been really compared in 2008 when we had about 210 millimeters, which is barely enough for a barley crop. In spite of that, those two synthetics gave 1.6 and 1.5 tons compared to the best line, which gave about 1.1 tons per hectare. This is one example, or this slide shows the desirable traits that we are really getting from the wild relatives. It is amazing in terms of new sources of resistance to biotic and abiotic stresses, as well as other desirable traits like earliness, like tillering, like also traits related to yield potential. Now, the other work that we are doing, we are working on durable resistance and tolerance to insect pest diseases and integrated pest management. The good example is the work with Morocco on the Hishane fly. And the difference here, as you can see from the slide, between a crop and no crop. So it is a complete failure. Any susceptible line will not even survive. The other example is the sun pest, which is a predominant insect covering about 15 million hectares in West Asia and Central Asia and Eastern Europe. The sun pest injects an enzyme which decomposes the grain gluten, which is vital for bread making. And if 2 or 3% of the grain is affected, the grain becomes, as you can see here, it becomes very sticky, and this is the type of loaf that you get. So the whole grain quality will be really wasted. And working with colleagues in Vermont University, we managed to identify different options for integrated pest management. We did find some predators on the eggs, and we also find some biotypes of fungi that can grow on the joints. The mycelium will grow on the joints of the insect to the point that within 5 days, 95% of the insects are killed. So this is one example where IPM has been very effective. Using this by the Syrian government on wheat, you can see how the use of pesticide has been really decreasing without affecting the yield. So this is one example where integrated pest management has been very good. The other good example is the work on rust. As you know, we had an excellent meeting before this event on the BGRI. We emphasize in ICARDA the work on yellow rust, but of course we work with our colleagues in Summit, on UG99 and other diseases. ICARDA distributes was distributing from Syria I would say the trap nurseries for rust all over the world. Now we are doing this now from Izmir in Turkey. We did identify new sources of resistance for rust to the new races that emerged in 2010 because of a warmer winter. And I'm not going to go through the details of some of these slides, but what I wanted to say, through fast-track varietal release and accelerated seed multiplication and delivery of rust-resistant varieties, there has been quite a bit of projects that were successful in replacing susceptible lines with resistant lines at the national level. The example is the USAID Famine Fund, which covered Egypt, Ethiopia, and Pakistan to distribute resistant varieties to both yellow rust and UG99. And there are 3 bilateral projects in Ethiopia supported by USAID, and Iraq also by USAID, and Pakistan by USDA. All these projects aimed as replacing the susceptible lines with resistant lines. This is the example here about the amount of seed that has been distributed. Those varieties are released by the national programs in collaboration with Summit and ICARDA. I want to mention the very interesting work in Ethiopia that if you see the last line here, that through the public sector as well as the partnership with the private sector, the distributed seeds in 2012-2013 were about more than 500,000 hectares, which is a tremendous work that should be commended. The national program should be commended for that. This is an example of the USAID seed project field inspection day. This is the example of a farmer's day of the USAID seed production project. Now, of course, the same thing has been done in Pakistan and Iraq. I'm not going to go in details because of the time, but all of this lead really to desirable varieties with desirable traits. This slide shows to you the number of varieties released in the durum and bread wheat since, I would say, between 1977 to 2013, 376 varieties. But more important than releasing varieties is the adoption of the varieties. I will talk about that later, but these are the desirable traits that are in the varieties. This shows to you the recently released wheat cultivars by NARS in collaboration with ICARDA, and I would like to say that the yield potential is really high in some. These are the varieties released in these countries. After that, we have the yield potential of these crops combining drought tolerance, the Hessian flight resistance, and this combines heat tolerance, as well as this is in case of spring wheat, up to 11 tons per hectare. And when we look at the potential in durum wheat, we have up to 14 tons per hectare. This is in SIDS in Egypt. Bridging the yield gap, this is very important aspects in order to reach, I would say, I don't want to say self-sufficiency, but to bridge the gap between consumption as well as use. This shows really the yield gaps in different countries between what the research can do and what the actual production is. I will move quickly because the time is running out. This shows the yield gaps in different, this is what have we done in Syria in terms of bridging the yield gap with the national program. Syria used to import wheat in the 70s and the 80s, but in the, I would say, between 1991 to 2004, wheat production rose from 2.1 million to 4.5 million tons, with a combination of new high-yielding varieties was for 1/3, supplemental irrigation 1/3, and inputs 1/3, and supporting environment. This shows to you that the area was not increased while productivity was increased here vertically. Now, this is the result, again, of an integrated approach involving sustainable natural resources, management and inputs, crop genetic improvement, and socioeconomic policy and institutional support, and the challenge is for the integrated approach. This same concept has been used in different countries of the region, and this is Egypt, Yemen, Morocco, Sudan, and Syria, and the average yield increases is 25%, while the maximum yield increases was 75%. This is the example of the raised bed plantation with improved varieties in Egypt. Look at the wastage in water, and look how the broad bed can easily enhance the water use efficiency. And the beauty of this, along a whole province, the productivity of a wheat was increased by 30%, while the water saving was 25%. This is an example of how can we produce more with less, as has been mentioned earlier, again here by the colleagues. Let me go quickly. The other example is heat tolerance in Sudan. In the past, before these varieties were available, the wheat was not grown south of Khartoum in the Jazeera. Now it is grown in the Jazeera. So let me move quickly to the last point, partnership and collaborators. All the work done by ICARDA and wheat is aligned under the wheat CRP, which is CRP 3.1, led by CIMMYT in collaboration with CIMMYT and National Agriculture Research Systems, advanced research institutions, IFAD, FAO, and other organizations, civil societies, private sector, and donors. In conclusion, the future emphasis, we believe strongly, should be on establishing, strengthening multidisciplinary, regional, and international cooperation and networking through the wheat CGIAR research program, strengthening the consortium on hybrid wheat and innovative research to enhance yield potential, including working for developing C4 wheat and nitrogen fixing wheat, strengthening the use of biotechnological tools, including genomic selection approaches, sustainable intensification of production system, strengthening and promoting integrated pest management, promoting further conservation agricultures in dry areas, and enhancing water use efficiency through deficit and supplemental irrigation, improving access to improved seeds through effective seed production and delivery system. Finally, capacity building is very important, and networking. This is, again, a dear slide to me, where it shows Dr. Norman Borlaug in 1975 with Dr. Bob Havener, at that time the director of the Ford Foundation, selecting the site of ICARDA. And very frankly, when we tried now to look for a site that may represent Tel Hadia in terms of its sort of typical features for non-tropical dry areas, it was very difficult to find a site as good as Tel Hadia. This shows the vision of those people at that time when GIS and remote sensing was not available. And thank you very much.